In this video, we're going to talk about reference angles. Reference angles sometimes remind us of coterminal angles, but they are actually somewhat different. So a reference angle is going to be important for us to begin to move away from finding trig values of trig functions just for right triangles, angles and right triangles, and instead for any angle. So the reference triangle, reference angle is the angle formed by a triangle where one side is along the x-axis. So, for instance, let's say that I had this blue angle here, right? And we'll call this theta. The reference angle would be, we're going to do is we're going to take this line here and we're going to draw down to the x-axis and we're going to make a triangle. And this angle here, which we're going to call theta prime, that's the reference angle. So an angle and the reference angle together are related to each other. And so you might even have, maybe you have an angle that goes like this. So this is your angle theta. Again, the reference angle is made by taking the terminal side of the angle and drawing a line either up or down to the x-axis. So in this case, this is that triangle I have, and so theta prime is actually contained inside here. It's contained inside part of theta. So the reference triangle, I cannot spell that right, reference triangle, and hence the reference angle is formed by drawing a vertical, so vertical means up and down line, right? Up and down line to the x-axis. So let's do some examples here. So for example, find the reference angle for 120 degrees. So I always think it's easiest to draw these. So 120 degrees, remember each quadrant is 90 degrees here, right? This is 90 degrees, 90, 90, 90. So 120 degrees would be in this quadrant here someplace. So from here to here, we have 120 degrees. So to make that reference angle, we're going to drop this down. So I drop down the vertical line, and we're talking about this angle in here. So in this case, these two angles together make up 180 degrees. So if this first part here is 120, this part here to get to 180 would have to be 60 degrees. So this reference triangle here would be 180 degrees minus 120 degrees, or 60 degrees. We'll do another example here. So find the reference angle for negative 285 degrees. So again, right, negative 285 degrees. So that's an angle that's spinning in the negative direction, right? So this is negative 90, negative 180, negative 270, so it's someplace over here. All right? So this is negative 285 degrees. And that reference angle, again, it's going to come from dropping a line down here to make that reference triangle. So we're talking about this angle. So all together, that 285 degrees plus this part in here has to give me 360 because it closes this whole circle, right? Together, this black part and then this pink part makes a whole circle. So it's going to be, in this case, 360 degrees minus the 285 degrees. And if we, whoops, dropping stuff off my table here. So if we do that, we end up with 75 degrees. And reference angles, they don't have to just stay as, you don't have to do them just with degrees, you can do them with radians as well. So for example, find the reference angle. Or minus 2 pi over 15. Now, most people have a hard time kind of visualizing minus 2 pi over 15. So if that is the case for you, and I think it's a little easier, you can always convert this to degrees, right? And it's just in the end, we're going to have to convert it back to radians. So minus 2 pi over 15, to convert it to degrees, I'm going to multiply by 180 degrees over pi, right? So my pi's would cancel. And we're going to have 2 times 180 divided by 15. So that's going to give us negative 24. So we're talking about negative 24 degrees. So if we think about it, negative 24 degrees, we would be going this way, negative 24 degrees. Now, the reference angle, again, I'm going to draw up to the x-axis. So you're talking about this triangle. So in this case, the reference angle and the actual angle are the same, but the reference angles that we're going to give, so the reference angle here is actually going to be the same, but that reference angle is going to be a positive angle. So for us to look at it here, the reference angle here is actually going to be positive 24 degrees. So because we're just talking about if we were just looking at this right triangle, right? Forget where it's located. So the reference angle here happens to just be 24 degrees. Which, remember, we have to change back into radians because my original problem was in radians. So again, to go back to radians, we're going to have to multiply by pi over 180 degrees, and that's going to end up being 2 pi over 15. Now, it's not always the case that it's going to turn out to be the same, right? It just happened to be that way because I happen to be down there in the fourth quadrant. So that's just something to keep in mind, that each of these problems is really individual, and you kind of need to draw it to figure out where things are going.